Welcome to Land Language, the podcast transforming landscapes from toxic to regenerative. We're your host, Brit from Blueprint Earth,
and co-host Bethany from Bethany Rydmark Landscapes.
We explore beautiful, functional design through conversations with scientists, vendors, contractors, and designers who are changing the industry.
Whether you're in the field or at the drafting table, join us as we explore regenerative practices that care for people, place, and planet.
Let's dig in. So today we get the honor of having Nick Tomasini in studio to talk with us about soil health, soil regeneration, soil structure, all things so incredibly geeky and wonderful and close to my heart. I feel very passionate about making sure that our soils withstand time and are something that can move forward into future generations. And I have so many questions because even practicing for 15 years, I feel like I don't know nearly enough.
I have days like that too. I think it's just one of those things where you're going to be learning about it, learning new things forever. And I think that's the right mindset too, to approach it with, because once you think you've got it all figured out, you've got some hard truths probably coming.
Nick, I'm really curious, before we go into all the questions and answers, were you a little kid that played in the dirt? And how did you end up in this world of soil?
I was raised more rural, and we were just outside getting dirty, building forts, playing in the mud, tree houses, bikes, all that kind of stuff. And we had big gardens, and we had some animals and stuff too. But I wasn't brought up on a farm, so to speak. So that happened later on as I got more into gardening, and I was going to school at Oregon State University and took some horticulture classes early on, found the Organic Growers Club there, and just decided to go all in and go that direction with it.
That was undergrad?
That was undergrad, yeah. And haven't looked back. It's been 20 years in agriculture. I've worn a lot of different hats at this point in time, and now mostly focusing on consulting. Humankind Oregon is my consulting company, so big focus on soil biology too. So we will talk about some soil biology through this. I've been doing that since 2016.
What have you seen change? You said 20 years. What have you noticed that's changed in 20 years' time as everything continues to change all the time?
Yeah, that's a really good question. When I was in college, the buzzword was sustainable, and it's still a very relevant term, sustainable and organic. So I really wanted to learn more about that, get into that, and as I became a farmer, I was a research assistant. I worked in large-scale ag, learned some more hard truths through large-scale ag. Mm-hmm. After that, moved out to Hood River, doing some organic farming, apples, vegetables. Worked for Oregon State Extension for a soil scientist as a research assistant out there. So I got a pretty clear view of conventional ag through all that. And I knew that's not where I wanted to be. I was young, and so I needed to take the opportunities that were in front of me. And I also feel now that it's really good to have that knowledge of conventional agriculture, being somebody that's trying to help people with managed transitions to a organic or regenerative approach. So soil health. But I would say what's changed is there's more of a buzz now. There was a buzz back then. It was slightly different, but now we're seeing larger scale land managers and ranchers coming into the space and moving cows around in a more methodical way, aiming for diversity on the range and in their pastures. As they say, it's not the cow, it's the how. There's a lot of different ways to raise livestock, and I think a big focal point in the regen movement is that livestock angle and what those animals can bring to soil health if raised appropriately. So I would say there's more of an awareness around pesticide and herbicide use. I don't know if the chemical glyphosate rings a bell for you,
Absolutely.
But it gets talked about a lot. And I'm sure in the industry you guys work in, it's used a lot. The word comes up. The conversation probably comes up a lot. How do we control these weeds? But I think it's the agricultural chemical that's used worldwide more so than any other. And there's some big implications around that. Endocrine disruption. Not to go too far into that, but I think there's more of an awareness around chemical use. I think there's also a movement toward nutrient density in food and realizing that the produce our grandparents were eating was much different than what we're eating now in a nutrient density or nutrient integrity sense. People want to know how to fix that. And I think soil health is the central theme with that. Seeing physicians, just people from all kinds of backgrounds come into this space and realize that it all starts with the soil. And from there, we can do a lot. Food is medicine, healing ecosystems, all of the above. So yeah, I think the awareness, it was big back then, but I think it's much bigger now, and it's shifted a bit. We've identified some more issues within agriculture and land management. And I'm assuming probably in landscape design and landscaping as well. So I would maybe turn that question on you guys. What are your clients asking different questions now? Are they asking about these kinds of things? Are they interested in soil health and avoiding exposure to chemicals and pesticides?
I would say that exposure to chemicals and pesticides is definitely what our clientele show up with. I think soil health is something that we teach to clients, and I think it's something that they may have heard of, like you're talking about with the nutrient density in food. They might start thinking about soils being lean. They usually see it from the perspective that they've moved into a new construction home and the topsoil has been taken away, so they end up with really lean soils, and they're starting to see that their garden, usually perennial, doesn't thrive like their last garden did that was an older home. And usually it comes from just like the problem and not really understanding that the solution is really in the soil. And in our industry, the challenge is that it's not a very commonly spec'd element of landscape design. And I think that just comes from the fact that it's not very well understood how to do something about it and what the implications of doing something positively is for a landscape and for food production, and how to take steps towards that, like what to analyze, what to integrate, and how to even assess what a soil is so that you know where to go from there.
Yeah, echoing that. I think our clients over the years have become more aware. Some of them will geek out. They'll come and they'll find us and they'll have been reading The Mother Tree, or they'll be understanding more about mycorrhizal relationships and working with us to say, what can we do to do better? How can we make our soils robust? How do we understand alternatives? And that's where I'm excited, because that's the cutting edge of clientele that's already here and wanting it. And then you go back to the other end where you have folks that really have no wish list for their soil at all. They just want a beautiful garden. And our job is to try to recommend the input and the expense and the investment at the beginning for what is invisible, quote unquote, but is the foundation for a thriving, healthy garden in the long term. And I think as a practitioner, we have the old specs of what's always been done, right? Here's a good 3-way blend. And previously you'd go and just till it in. You'd spread it around and till it as an even thing and rototill the whole thing. And now you've got a nice fresh starting ground. Of course, over the years, we've learned more, and I'm curious to hear your feedback as well. We've started to understand you don't just go break everything up. You don't destroy all those hidden relationships, but then there are reasons to and not to, and that's venturing into the discussion of confusion where we want to do better and we need to understand those places for doing better. But I guess at the heart of it for myself, going back to, I actually come from those farming roots in the Willamette Valley. So I grew up on industrial farms with huge swaths of land and large crops of primarily grass seed and other things as well. But I'm also very aware that in previous conditions, we had a river that would braid itself across the landscape. The edges would shift and the soils would wash in different directions and water would do things to move it around. And there was just this very living kind of valley. And that's why we have this incredible Willamette Valley full of production. But over time, we've boxed ourselves in with all sorts of choices and replicating the same cookie cutter things. And now we're at a place where soil is not as healthy. And you take that down to the residential scale into a neighborhood where maybe they've in an old estate, maybe in an old corner of the city, maybe you have old original soils that have some life and some robustness left, or you go to a place where they've scraped it all off and taken it somewhere else, and now you're trying to build a brand new garden in something that's barren and void. And so that's what I encounter, is that we have a growing awareness of what's not working. We have certain people that are really excited and want to like inoculate soils with brews of all sorts of interesting things. And I'm just still learning and absorbing and figuring out how to recommend that and experiment alongside of our clients. And then we have the folks that are a little slow, but I think would be really curious to understand this is an investment I can make now on the front end to build something that will support an overall healthy environment, healthier plants and creatures around me, beautiful, so that's psychologically healthier, who wants to look out and see things that are brown and yellow and struggling versus something that's robust, thriving. And I guess that's a mirror to us as humans, right? If those things around us are thriving, we're probably also healthier. Maybe we're eating those old carrots that are full of all sorts of good things instead of the ones you grab at the store that are orange but nothing to them. So
You would have to eat like 80 of them to get the same amount of beta carotene that our grandparents were getting.
yeah, exactly. I don't know. That's my perspective now. I do feel like we're sitting in an age where we have more awareness, more information, but I'm still a little less confident to know then, okay, how do we throw out the old specs and figure out the better new ones? How do we go forward in a way that's responsible with our inputs and our finances, our clients' trust, our contractors' time? That's from my perspective as a landscape architect.
Yeah, I think the question of what is the status of this soil basically informs what to do next. And within agriculture, I think we've tried to eliminate all the variables. So essentially, like all the life, all the trees, all of that interfacing with nature, not everywhere and not in all cases, but within conventional agriculture at large, I think that's been a focus, right? And then we come in and manage it with man-made chemicals, and then problems come because we don't have any natural predators or anything like that. So then we're managing with insecticides, fungicides. Exactly, exactly, yes. If it's a construction site that you're inheriting as a project, maybe some prescribed cultivation is the way to go to begin that. How many layers of compaction are there? How bad are they? What's the soil type? Over here in the Willamette Valley, there's quite a bit of clay. So compaction is like compaction on steroids, right? So going in and mitigating or remediating that scenario, I think, is important at the outset of a project, right? Because maybe over time, roots and microorganisms can rebuild some structure in there, but they will struggle. There's just not going to be good levels of water infiltration, of gas exchange to support life. So going in and breaking up what has been maybe anthropogenically created there is probably a good place to start. So without no-till is a great thing, but within a context, right? What are all the variables here? How do we start out on the right foot? And then we can start to do things, reset things, and maybe you're doing soil testing and you're bringing in amendments and other amendments like compost to increase organic matter there. How do we choose those? I think that's a conversation in itself.
Where do we test?
Yeah.
Where
There's
can you
so
go to
many
test?
ways
I know.
to go there, right? So as we get into the soil health thing, I think first and foremost, just a soil chemistry test is going to be your best bet. What's going on? What's the nutrient profile? And then there are a lot of different schools of thought within that. So which lab is going to be best for your approach?
Yeah.
And so for me, because you'll probably ask me,
Yes.
I am a mix of the Dr. William Albrecht style of mineral balancing in soil and the more commonly used SLAN approach, if you will, which is like the sufficiency level of available nutrients in your soil and looking at things from that standpoint. So I like to look at those two things together when it comes to soil chemistry and how to interpret what's going on in a soil and what types of minerals and what rates we would potentially use. And things that I think about, since we're talking about structure, calcium, these cations, calcium, magnesium, potassium, sodium, and their balance with regard to one another. We usually look at it as a percentage of how much of the soil colloid, the total soil colloids, those minerals are adsorbed to, right? With clay soils, we've got a lot of colloid or exchange sites. And typically we're looking for calcium to be like 65%, 60, 65, maybe up to 68%. Magnesium, 15, 20% of that. Over here, you've got a lot of magnesium. It's hard to pull that out of your soil. So really, we're just looking to bring levels of those that are outside of their target percentage up, and that will in turn decrease that magnesium percentage too. But the reason, one of the main reasons, is structure. So we can think about it very simply. Calcium, if we're talking about lime or gypsum, oftentimes people are talking about pH, but also calcium is a nutrient, but it softens soil. So it actually allows clay particles to flocculate. So instead of being stacked on top of one another, calcium is a pretty big molecule, calcium 2+. So it can actually create this kind of a restructuring within soil. So that's one reason why we look at calcium firstly. And as we talk about like the soil structure, if there's a way to intervene with minerals, calcium is going to be a good bet there, especially on this side of the Cascades where you get a lot of rainfall and your pH is also pretty low unless you've been working on pH. pH is in the 5 range are probably pretty common unless you've been applying something like lime. I live on the other side of the Cascades where it's full of alkalinity. So our pHs are like 8. So we wouldn't need any lime over there that would push pH up even further. We'd be looking at things like gypsum or volastonite, which is calcium silicate. But so those, structurally speaking, that's where I start. Like, how do you get in there and remediate what's going on physically? And then how do you change that mineral profile to support structure over time? So I think that's a good starting point, is just doing that kind of soil testing. But from there are a lot of other types of soil tests too that I think are important.
That's fascinating. So the structure being the first level of soil testing where you start, and then what comes next?
Yeah. Carbon, right? So there's a lot of talk about climate and carbon sequestration, and there are a lot of good reasons to put carbon in soil, to draw down carbon sequestration, soil health, plant health, all of these things are going to benefit from getting more carbon into soil. And so with a typical soil test, you're going to get like a percentage of organic matter, right? And that's good enough, but you can go deeper than that if you want to. The Haney analysis is one analysis where they actually break carbon up into multiple pools. So you can see like water extractable carbon, you can see total carbon, you can see organic matter percentage. You can also opt to have like soil respiration, which is a proxy for microbial activity in that soil and microbial turnover. Other things on the Haney too, without going too deep into it, every soil chemistry lab uses some kind of an extraction agent to essentially pull minerals and nutrients out of your soil sample. They've designed one that is more closely related to a root exudate.
What does that mean? I'm
Yeah.
expose my
Okay. So
ignorance.
speaking of carbon, right? We've got photosynthesis. We split CO2, and then we've got sugars being injected into the soil via roots. So those are exudates.
Got it.
This extraction agent mimics those exudates and gives you an idea of what from that soil could potentially be mineralized or solubilized and become plant available.
Okay.
Some of the other tests I was talking about, like mineral balancing, that's like a Melic-3 really strong acid, 2.5 pH. So that's going to pull everything out of that soil sample. Even some minerals in there, it's going to basically break those down, and they're going to come into solution and be picked up on your soil test. With this extraction agent, it's not quite so acidic and so strong, and so it gives you a better idea of what your plants can access from that soil.
Interesting.
Does that make sense?
does.
Yeah, it does. And that makes me start to think about like the biology of the soil, because then we're talking about what happens between the chemistry within the soil and how organisms help food get to the plant.
And that's actually my area of focus, is soil microbiology, soil food web, if you will. So types of testing, there are a lot. And this thing we're talking about here is like it's a black box. Soil carbon is too. And there's obviously a lot of crossover between microbial life and what's going on with these various carbon pools in soil.
Can you name off like the couple tests?
Yeah. So the one I do in my lab is a direct microscopy test. We do some staining as well, where we can see mycorrhizal colonization in roots, for example. But really what we're doing is we're counting out microorganisms that we can see that are active in these soil samples. We're looking at bacteria, actinobacteria, beneficial fungi, 3 groups of protists. Those would be flagellates, amoeba, and ciliates. We look at what are potentially pathogenic fungi in those samples, or oomycetes, water molds. And then we're looking at 3 or 4 groups of nematodes as well. Bacterial feeders, fungal feeders, predatory nematodes, and then root feeders, which we hope not to find. And that was established by Dr. Lane Ingham. Like, that's her methodology. And over 45 years, she's worked on that and has established these sort of optimum ranges, right? But there's a lot to that. So that's one type of test, right? We could talk about that the whole time. But there are others that I think are just as common, if not more common. And there's a lot of new technology too. But a PLFA test is one that I'll often pull in conjunction with the Haney that we were just talking about. And that is a phospholipid fatty acid test. And so they're also looking at not down to the species level. We're also not looking down to species level with a microscopy test. But they're looking at these different PLFA signatures from various microbial groups. And they're giving you a very similar kind of biomass and population report for protists, bacteria, fungi, mycorrhizal fungi. So that's a good one. I think those are fairly easy to read too. And then from there, the other one that we do is a 16S genomic test. So that is basically characterizing all of the bacterial species in your soil. So usually we can see anywhere from 500 to a couple thousand species that way. And then there's an ITS test, which is another genomic test, and the same lab does this one. That stands for internally transcribed spacer, and that allows you to identify the fungal side. So then you get into seeing a species list of fungi. Maybe there's 400, 700, 1,000. And for me, I like to pull 2 of those where I can. Not every project is going to allow me to spend that much money on testing, but where I can, I like to be able to paint a broader picture like that. So if I'm doing microscopy, that's my bread and butter, because what you see is what you get. Those living organisms are there. With DNA, there are sometimes issues with just there being relic DNA. These are not living microbes anymore, but they're being picked up and quantified, so you don't really know. So when I have the microscopy data and a species list, that's just very helpful. Because even if I'm just looking at the top 10 that are coming off of those DNA tests, it just provides a lot of information there.
So if you end up with one of these naked construction site soils, would you pull all of those?
No, I would pull 1 or 2 of them.
Okay. Are you mostly focused on like the structure of it because you're not expecting a lot of life in it?
That's typically what I find when I do a soil analysis for a landscape soil or an ag soil. Now you look at a forest soil and it's a totally different type of sample. If you're geeky, you're going to spend maybe 2 hours looking at that sample just with all the different kinds of life in there. Unfortunately, with our ag soils, with our highly disturbed soils, it's a bacterial overgrowth, if you will. So we can be counting 10, 20,000 micrograms of bacteria per gram in that soil with not much other life. That's a really common outcome for those tests. So it doesn't surprise me when that's what we see. And I typically know
How does that happen?
what we need. Yeah, I think the disturbance is,
Just the disturbance.
and there's so many different types of disturbance, right? So obviously, if we're talking about one of these construction sites, maybe from the time, if it's around a home or something, maybe from the time that foundation was poured, they just wanted to compact that and make it a feasible place to build.
Yeah, it's their material stockpiles.
Yeah,
spot.
yeah. And at the same time, we end up in a similar place in agriculture too, because there is just so much tillage, which exposes all the organic matter, exposes all the organisms, disrupts them to no end. It creates a very oxidized environment where the bacteria are chewing up all of that organic matter and then respiring it back into the atmosphere. So we're in one of those cycles with agriculture too, and just the extensive tillage that's going on. And there are ways to come back each season and try to do your best with soil health still. And I work on a lot of projects like that. But a little bit of tillage is one thing. Let's say low till, but a lot of tillage it's just too disruptive. If you look at ecology in general, where there is a high degree of disturbance, there's low diversity. And it's just always going to be the case. But if you look at like intermediate disturbance theory, then a little bit of disturbance can actually lead to more diversity. So it's a spectrum, and I think there's a lot to work with that. But on the microbial side, just not having that diversity is basically the loss of functionality in those soils.
What happens when a soil doesn't function? Does it become like, I've smelt soil that smells anaerobic?
That's when you've gone way too far and you just need to let it dry out or whatever is going on with it. Let those anaerobes off gas, whatever excess nutrients are in there, if that's part of the problem too. Just get some oxygen back into that situation.
Is that when you start to kind of break it up to introduce oxygen, or just literally let the organisms?
Again, I don't run in, it has happened, but I don't often run into scenarios with soil where I can smell it. And when I can, yeah, it's almost like, do I want this project or not?
Something's clearly wrong here. I asked that question because when I have seen that, it's been in the context of people trying to create raised beds. And I know one of the projects we got to work on was around how to create raised bed soil and how to look at the inputs we're bringing to really create something that is going to be useful, and then also around like where to buy based on some of the testing that you've done.
Mm-hmm.
But yeah, usually it's that raised bed where I've seen anaerobics.
So just to finish up on that structure side,
Sure.
that fungal life missing
Uh-huh.
and not having that living root, that is huge for structure. So when you don't have that fungal network, if you will, those strands, those filaments, that hyphae, right? Your structure is going to collapse, especially if it's a bare soil too. So if you have no fungi and you have no living root, and then there's been a lot of disturbance, you're in worst case scenario there, right? In terms of soil health and just having a productive soil. So a lot of what we're seeing with the testing is just a lack of fungi in general in these soils that have been used for landscape, construction, agriculture. Mm-hmm. So that is often task number one after breaking that compaction, addressing some minerals, getting a living root in there. How do we start to reestablish some of these inoculate, compost extract, compost tea, various inoculants, right? But as far as raised beds, typically we're talking an engineered soil in that case. I've worked pretty extensively making custom soil blends for various market gardens, cannabis growers, landscape, etc. And there's different ways to go. So you can do like a peat moss or a cocoa based soil, a typical potting soil that has aeration with like pumice. Let's say 1/3 peat moss, 1/3 pumice, 1/3 compost, and then some kind of a nutrient charge you put in there too. So for me, the process is, first of all, let's look at all these base ingredients. Let's test the compost. Let's do a compost test. And that's actually what it's called. So you can send off to labs and get a compost test. And it's just going to give you all the elements that are in there, the moisture, the carbon, all that kind of stuff. You can go further and look at heavy metals, which is probably a good idea depending if you're going to be eating from that. If there's any question about the sources that you're going to be using, it's best to test for sure. So clients rely on me to give them good information and build a good mix, and I can't build a good mix if I don't have that information. You can also, and you guys, you work with these mixes too, and maybe you formulate them yourselves, but I actually prefer for a garden bed, a raised bed situation, I just like compost and topsoil, and then I like to go from there. Potting soil has its use, greenhouse, nursery, and it works great in raised beds too, but my personal preference is just to get some clean potting soil with some decent compost. I'd love to have amazing compost, but as it turns out, that's not always easy to come by. So just the best compost that I can get. And then I like to build soil health and structure and a functioning soil food web or microbiome from there.
So you would test your compost that you are going to bring in before you bring it in, and then know a little bit about the microbiology of your topsoil.
Yeah, I want to know how much sodium is in there. I want to know how much chloride is in there. I want to know about those heavy metals for sure. It costs a little bit more money if you want to get a full pesticide screen too. We're talking more like a $500 test. I should say those DNA tests I mentioned before, that's more like a $250, $300 test too. So not everybody wants to do those. But These pesticide screen tests are very expensive and they take a few weeks as well, typically. In this area, Pacific Agricultural Labs is who I would use for that type of a screen. When I worked for Oregon Till Certified Organic, we had to do residue testing in soils and on crops, and they would give us a screen for 500 different common pesticides within agriculture or landscape. So if you want to do the extra credit, you could go that far for sure.
What happens if you find them in the soils? How do you remediate a site like that?
That is also a whole podcast in itself.
Okay, I'm super curious.
But I think we just have to be a little careful with that. First of all, what is there? Are they polycyclic aromatic hydrocarbons that we can maybe find processes and organisms to break those bonds? Or are they high levels of heavy metals? And where are they going to go?
Phytoremediation podcast coming up one day.
Yeah, so phytoremediation is a great way to go because then at least you can pull some stuff out and then what do you do with it from there? I don't actually have solutions or an answer to that. With bioremediation or mycorremediation, which is in vogue now as well, and heavy metals specifically, you want to get them immobilized on something, right? So there's different ways to do that. I think biochar and wood chips are good candidates for that. If you're cleaning up an old mine site, this is something that I was talking with some peers about recently. How do you do it? What are the risks? It was arsenic in this case. And arsenic has a lot of different oxidation states. Depending on which one it's in, it can move around or not, right? So wherever you're starting oxidation state-wise with arsenic in this mine site, let's say, you're going to go in there and probably want to do something to just make sure that it's immobilized. So adsorb to maybe some naked uncharged biochar with some layers of wood chips on top of that.
So it's a binder. Biochar is a binder in this situation.
Exactly.
Okay.
And so are the soil colloids. So you've heard the term like cation exchange capacity. Yeah. Typically what we're talking about are negatively charged with a very high electrostatic charge surfaces or substrates. It's magnetic. Mostly they're negative, but organic matter can be both negative and positive. But with these colloids and with biochar, we're mostly looking at like cations being absorbed, so positively charged ions. And arsenic is a cation, so that would work really well there. I think with biochar, you get negative exchange sites too. So just to throw that out there to make sure I'm not saying anything that's untrue.
Biochar kind of becoming a staple in your guys' practice? It's such a hype word right now, and there's so much around how it's being made and if it's...
We've had entire landscape architecture discussions, presentations on biochar.
Yeah, I'm going slow with biochar, but I'm also getting pulled into it from all sides, including within soil where we were already making some biochar and trying to figure out how to best use it. But I've had to charge biochar for various projects where people really, either they created biochar on site or they were just really hip on using biochar, and it needs to be charged because it is so electrostatic that it will pull everything. So if it's in a productive type of soil where you're growing crops or landscape, it can sequester or adsorb a lot or immobilize a lot of what's there.
What does that mean?
So let's say you've got a soil that's slightly low nutrient scenario, but the plants are thriving there because they do well under low nutrient conditions, the high nutrient use efficiency, right? And as they drink water through their roots, they're getting minerals from the soil. And if you come in with a bunch of uncharged biochar, it's going to grab onto a lot of those minerals. It's very hungry in that way. It's magnetic in that way. Yeah. And that is potentially going to take it away from those trees or those plants. So that's where this whole idea of charging it comes from.
What is that? How do you charge?
You're essentially just putting it in contact with minerals and microbes.
Oh, so you're literally just, hey, charge...
I'm not gonna pretend to know the absolute best way to charge biochar. Sure. I know there are people that do have strong feelings about how to best do that, but again, I'm taking the slow approach to it, and I've got a handful of projects where I've gained some experience with that, and some have been surprising, and others have gone the way we anticipated, which was good because again, I'm a little reluctant to, it's not something that I'm recommending for projects most of the time. And for a little bit of a visual or a way to think about biochar, it has a lot of surface area. It's got a lot of pores. So we're talking about 400 square meters of surface area per gram of biochar.
Whoa, say that again.
400 square meters of surface area per gram of biochar.
That just blew my mind.
There's a lot of hype around biochar, and this is why I think it is a very powerful thing. I just don't know how to best use it. But
Okay. So don't go jumping down the biochar train.
I'm not going to say that.
Educated on
I
it.
think you should definitely do some homework first, and there probably are companies out there selling charged biochar, and that might be a safer way to go.
But just being aware and thoughtful that there are these different conditions.
Yeah.
That's something probably in my world where I haven't had a lot of opportunity to
Yeah.
spec it or use it or be around it,
Yeah.
other than just hearing in the industry that there's this
Yeah.
gravitational pull toward, hey, there's this new and helpful and useful way of integrating something, but to know even from your warning that you can receive that material in different
Yeah. Okay. So
conditions.
right. So quick story. I used a micronized biochar, which is basically a flowable or an injectable. So you can mix it into water and then you can irrigate it in. And we did our best to charge it up and really make sure the carbon to nitrogen ratio in that mix was what we thought was sound, somewhat balanced. And this was in a potting soil, and that crop showed signs of yellowing within 48 hours.
Oh, whoa.
Because there was
It-
no nitrogen. Was
Because it just
dropped?
grabbed on to so much that was there that plant was used to receiving and brought it to that point it was at in its cycle, right? And then that was disrupted. So I'm just saying it warrants respect for sure, biochar.
So is it like a paint color in a room where you're like, I'm going to try it on this wall over here with a little bit of this lighting, that
I
wall
think
over
anytime you have questions about something or you're
Yeah.
unsure, that's a good approach.
there. Okay, rather
Yeah.
than just start specking biochar as if
A lot of my
it's
projects have
charged.
just started with trials.
Yeah.
Okay.
They just want to have a control. They want to replicate it a couple times. They want to see how it goes, and then we'll go from there.
I love that. I love this conversation too, because like I would be like, oh, should we be specking biochar on these naked sites, especially when there's super clay and compost? And sometimes the feeling is, oh, is more, but really it's
This is
dangerous.
another one where I think less is more. Yeah. And when I say another one, I feel that way about kelp and several other inputs too. We don't need to get all the way into that now. But with regard to bioremediation, it's just so powerful that it seems like it would be a good candidate to grab on to a lot of that. And then I said, with regard to this mine where there's arsenic contamination, if you got some biochar in there to immobilize it or to grab onto it, right? And then layers of wood chips on top of that, which are used in a lot of biofiltration and a lot of remediation too. They've even had trials or studies where they've inoculated with various fungi that they know to be able to bioremediate things. And then they have a control that's just wood chips, and the wood chips work just as well, if not better in some cases.
That's cool.
Facts of
Right.
nature, was it?
Yeah. So I'm a big proponent of wood chips for sure.
Any
But
particular species of wood? Any-
oh boy, yeah. I like a mix for sure. 55 to 60% wood chip is how it starts. So we use a blend of a lot of fir, a lot of conifers in there, but other softwood, hardwoods in there too. A blend works very well. We like diversity. We want a diverse microbial outcome. Diverse feedstocks going in can be one way to get to that.
So don't just blanket something with a bunch of cedar chips and hey, there's something like
Yeah,
bring
no,
in-
that's a
bring
good
in
point.
a variety of species and they can all decompose and do their thing
And I-
in
Which is why
harmony.
We use that. Like Bethany and I recently worked on a project where we spec'd airport bark, which is like a mix of the trees around here,
Yeah.
nondescript.
I also prefer,
Slightly
if not up
aged,
to a
yeah.
year. So a lot of those volatile organic compounds that you can smell, they're aromatic, have dissipated because they are antimicrobial. They can just create some other issues. But just to close out on that bioremediation, the issue I think on the heavy metal side is that you run the risk of remobilizing, because once, if you're putting a bunch of compost in, then you're bringing in new species of microbiology, and some is not going to do well in that environment, but some may actually find a foothold, a resistance, and could potentially change the oxidation state like we were talking about of that arsenic and remobilize it, and it could get into the waterways that way. So even with just using wood chips and biochar, those are fantastic substrates for biofilm to eventually form. So once that biofilm forms, it's colonized, they're interacting with this highly contaminated site, like what happens with the arsenic? I think we know a lot. We've done really good work. I think breaking the bonds, carbon, like with glyphosate, we now know there are several species of fungi that can break that phosphorus carbon bond and that organophosphate. Once it's carbon and it's that phosphate or that phosphorus, whatever form it is, it's not nearly as harmful, right? But with the heavy metals, where do they go? So I think that's the main difference
Interesting.
there. So it depends on what kinds of contaminants or pollutants you're dealing with.
And it sounds like you guys, as a community, are still trying to figure out how to deal with the heavy metals in terms of when you get them out of the soil. How do you keep them bound, or how do you get rid of them if you can, or
Yeah.
where you get rid of them so they
Yeah.
can accumulate?
Well, yes. I was working with this group, and we were going to put in for this grant to clean up this contaminated neighborhood. So it was an urban area, right? And we started getting into some of these questions, and we decided not to do it because we were like, we don't know what's going to happen with those contaminants, because they're really into biochar, and I was trying to bring in the microbiology side of it. And we just got to a point where we were like, we don't really know. And is that safe? So we're not going to do this.
Like, actually spread it out, it sounds potentially.
Which just makes me more curious. And there probably are some solutions out there that I'm unaware of, but these are just the things that have been in my purview as of late. And it just seems like biochar is coming in from all sides. And I want to know how to best use it. I need more experience.
I know we've really landed there because it's such a hype word right now in landscape. We've got more digging to do, I think.
And that's the thing, when we were talking about the trials, we don't always have, the budget doesn't always warrant a trial.
Right.
The client doesn't always want to spend that time doing a trial with this or that. And I bet it's even worse for you than it is for me. It just depends on the client and what the project is, I'm sure. If it's a native landscape or trying to build something that interfaces with that native ecosystem, maybe more time and consideration is taken there. And some of those principles, I'm sure, are used around the residences and projects you work on too, but maybe they don't want to spend the extra time and money to figure out the perfect approach. So I say, take the things you know to be most beneficial for soil and plant health and incorporate those, and the things that we're interested in and we would maybe like to incorporate later on, just keep working with those until you have a better feel for it.
What would you say on that note? What would you say on a residential scale are the key most important pieces, right? I can imagine like a composted bark mulch is going to build soil in XYZ way. What are the main things that if we can be advocates for clients to consider, spend a little extra effort or a little extra time or a little extra resource on these three things that will really pay off in the long run?
I would say, firstly, addressing that structure. Even if it's an installation that's already there and you're just coming in, add to it or revamp it to some degree. Maybe you could go in with something like a broad fork, even digging forks, just build some tilt, break that compaction layer. And so that would be the first thing, is addressing that structure. And from there, I would say what kinds of minerals and or mulch can be helpful here, or compost. And then beyond that, I would say the microbial side. I know there's landscape companies and designers that are getting more and more, or have been into the microbial side for a long time, but it seems like there's more and more interest there now. And so I would say, what are some focal points that we know to be beneficial to soil and plant health across the board that you could pretty much install in any project that you're working on? And you mentioned Mycorrhizae earlier, and so
I think that's a standard. I know when we spec soil health or in the projects that we construct, I want to know if this is good or if this is bad. I'm super willing to change. We'll go and we end up doing a lot of excavation because we'll usually show up because there's grading problems or stormwater problems, and that's usually where projects start being designed from. So we end up with pretty naked earth a lot of the times, and we've had to remove the top layer of soil in order to create proper drainage away from the home to protect the foundation. So our general spec is 2 inches of compost, and then we haven't been turning it into the soil. So it sounds like turning it into the soil, or at least like using a broad fork and breaking it up, would be advantageous possibly.
sometimes you have the option to do that, and sometimes you don't. And again, I think it goes back to, what is the status of this soil?
Yeah.
Do we want to disturb it a bunch? Is it already in decent shape, right? Some of these structural things not really addressed from the beginning. So it's okay to hit that reset button to some degree at that point in time. So I think, again, just like considering all the factors.
So like the way that we do disturb it, so we'll use like one of those giant Ryobi augers to make our planting hole, like disturb it in kind of a 2 times as wide as the pot sort of scenario, but don't go and necessarily break up the whole soil structure. And then as we plant, we bring in the organic fertilizer with mycorrhizae on it. That's our design spec standard and construction spec standard. And again, willing to change.
Yeah, no,
I'd
I
like to know
think
how to
I
do
think
better.
that's a good way to go. I think looking at what types of plants you're dealing with and what types of mycorrhizal species are in those inoculants is important. So a lot of your trees and stuff are going to be more on the ecto mycorrhizal side, where a lot of the grasses and annuals and even forbs and things like that might be more on the endo mycorrhizae.
Can
So
you say more about those too? Because I'm like, all right, I can go Google after.
okay, I could probably make this really
Yeah,
easy
like-
by saying that, by the way, I have no affiliation with this company, but MycoApply, mycorrhizal applications, they make most of the mycorrhizal spores, I think, in this country, and a lot of others are white labeling those. And I think their products are tried and true. They've been around for a long time. They're the ones I use in my projects, but they have one that is an endo-ecto mix. So you would get like the Lucaria, the Suillus, some of the Rhizopongan on the ectomycorrhizal side for the trees. And then you would get more of the Glomus genre species on the endo side for some of the other herbaceous, maybe non-woody stuff.
Okay, so it's one that we could bring and be like, all right, guys.
So either you
stick
have
with
to
this one.
figure out which species are going to associate with each thing you're planting,
Yeah.
or you can get the mix and then
Yeah.
cover all the bases
Yeah.
that way.
I
Yeah.
love that. And a lot of times,
They're injectable too.
great.
Yeah. So
Love
so
that.
even if things are already planted and you have a root injector, you can get in there and still inoculate.
Mm-hmm.
And if you're doing the mycorrhizae, you might as well do a good compost extract or something like that in there
Mm-hmm.
as well.
Yeah, compost tea seems to be the kind of follow-up that when clients are like, okay, what do I do now? Do I go and fertilize? And again, this is where I want to know from your perspective. I'm usually a proponent of don't fertilize and use compost tea.
We could spend a whole podcast on that one too. We want to enrich, but enriching too much, as I'm sure you guys well know, is maybe not the best approach. Think about a bunch of enrichment in a poor soil, and then 3 years down the road, all of a sudden it had all that food, and now it doesn't, and it needs to fend for itself, but it's in a poor soil scenario. How is that plant or that tree, how's it going to do? So when we talk about fertilization and minerals and stuff, I think being judicious is key. Don't front load things. Just come back more often if that's what needs to be done. We can talk about that in more context if you want, but they need to be able to fend for themselves to some degree, and while you're building soil health around that.
Does compost tea help them defend for themselves better than fertilizer, or is that very subjective?
I think with compost tea, it's not always what it's cracked up to be. It's easy to brew an anaerobic brew. Most people don't know what kind of microbiology is in the compost or the inoculant. That's a little easier because there's a guaranteed analysis. But with compost, you don't always know what's in there. Is there fungi in there? Are there protists and nematodes? Is it mostly just bacteria? And then what do we feed them when we're brewing a compost tea? So the resources. And if you give them a bunch of food, a bunch of sugars, those more opportunistic fast growers are going to get in there and they're going to use all that. But the other thing they're going to do is they're going to use up all the oxygen in that brew. And that is one phenomenon that occurs where a compost tea can go anaerobic, is just too much food, maybe not enough aeration, and a lot of activity as a result of that. And then once something goes anaerobic, probably you're not going to end up with a good fungal outcome at the end of that, or much protist activity, if you will. Can they still be beneficial if they don't have those things? Yes. But if you run them anaerobic, you might as well just use fertilizer and skip the compost tea. So I think there's a little bit to compost tea, where with compost extract, if you can find a good source of compost and throw some inoculants in there, some mycorrhizal inoculants, maybe some other bacterial inoculants, then all you're really doing is knocking those microorganisms off of that substrate or off of those compost particles into solution and getting them into the soil. So it's not a long process. You can do this in 5 minutes. Some people want to go a little bit longer. They want to mix some foods in there. They're going to do it for 30 or 40 minutes, and then it's going to go right into the soil.
What difference between compost tea and compost
Yeah,
extract?
compost tea you're going to brew for some duration of time, usually, let's say 19 to, some people will go to 48 hours, where with compost extract, again, you can do it in 5 minutes.
So you just like dump some compost in some water, straining it out.
Agitation.
Agitation.
Yeah, you can use the same like compost tea bags. 400 micron is what we use. but essentially to keep the compost in the bag, to get the microbes into solution still and not have a bunch of particle in there depending on how you're trying to apply it. If it's going through an irrigation system, if it's going through a sprayer, then there are some considerations there for sure. And sometimes even filtering multiple times if you're going to run it through a drip or a sprayer that has a tip on it with a really small orifice, because they clog and then all of a sudden you're just spending all your time unclogging your sprayer.
And then so you've got your compost and you have either made it at home or you are making sure that it's not a heavy metal compost.
Yeah, because there's a nutritional component as well in compost extract and tea. With tea, the whole reason you're brewing it overnight is because maybe you have a smaller amount of compost or worm castings, which would probably be a better bet for these types of applications than most composts.
Cool.
If you don't know what's in there, like worm castings is probably the way to go. Anyway, with the tea, you're actually getting these microorganisms to reproduce. So if we're on like 50 or 100 or even 1,000 acres, sometimes we don't have enough compost to make extract. And tea, if we have all the equipment and the know-how, tea might be a better choice in that situation. But as far as being foolproof and effective, because you do run the risk of going anaerobic with the compost tea, I think a compost extract is a better bet. And I think you're seeing growing popularity. Have you heard that terminology, compost extract? Yeah, okay.
No. That's cool. Go ahead.
Look it up after this because you'll see a bunch of information on it. And I'm happy to talk to you guys more about it on air, but off air too. With the compost we make, we're really focused on the microbial outcome, especially the diversity and the biomass of that fungi in our compost, but also the protists and the nematodes, which are in the third trophic level of the soil food web, if you will. So they're predators. So if fungi and bacteria are basically the decomposers in that system, we're not talking about mycorrhizal, more like saprotrophic fungi, they're holding a lot of nutrition. And so these protists and these nematodes can actually unlock that through predation. And so that's a big part of nutrient cycling in a living soil. So with soil health, we want to see some of these more eukaryotic microbes and their activity building structure, cycling nutrients, stabilizing more carbon as we build more fungi as well, which is a rad benefit. But we really focus on those microbial outcomes in our compost because we want people to make extract and or tea from our compost. From my experience, there's a little bit of a gap in the market with that quality of compost, and I use it in all my projects. But if I was unsure, I would look for the best worm castings I could. I used vermicompost in most of my projects, and I'll continue to use it, but that's probably your best bet if you're going to make some of these extracts. And teas, if you would rather do a tea.
And then you talk about inoculating it. So is that where we're bringing in some of the mycorrhiza, the mix of mycorrhiza into the compost as we're creating extract or tea?
The mycorrhiza needs a host. If it was in a tea, you would do it at the end. It's not going to do it might germinate in that tea, but if it doesn't have a host, I'm not sure if it's going to live through that process. There are others that would disagree. Maybe they're a little bit more experienced, but they want to wake up those spores a little bit through a brewing process before putting them in. But I say, just to be on the safe side, it goes into solution right before you do your application. But yes, absolutely, you can mix it in there. And that's something we're looking at too, because obviously mycorrhizal fungi is a big part of the soil food web. And we can't really produce that in our compost. So we've looked at potentially adding mycorrhizal spores to the compost, or maybe having one product where mycorrhizal spores are added. And then it's a lot closer to a full soil food web, if you will, which would be a more effective extract. But I also think it might just be better to do your compost extract and then buy your spores and just put them in last minute right before that application.
Got it. And mycorrhiza is so fine that I'm imagining it gets through drip irrigation or sprayers just fine too.
Yeah, MycoApply has injectable solution grade, but you can also get granular. Sometimes that's the way to do it. If you're installing something, granular might be better. But a root dip works really well too. A root drench, or basically right before it goes in the ground, you have your bucket. Compost extract, some mycorrhizal spores, and then right into the ground from there.
Which I wonder if I can sidetrack us for a second to talk about making things more accessible for contractors that we're asking to change methods. Something like that. That seems like a pretty straightforward idea to share with a contractor and say, hey, we'd love to get this set up. We'd love to have the crews out on site. And when every plant goes in the ground, give it a little dunk and go. I'm going to lead off with that and let you
I've had
respond.
to navigate this before, and I've had mixed responses from people. I've been able to get fairly large outfits that are doing the installation to do the dip, but not without some, it's like pulling teeth, right? It's cumbersome. It's an additional step. They've got to move it around. We're planting 80 acres of vines or something like that. And so there are some logistics to this, but the benefits certainly outweigh a little bit of extra time.
Thinking about small scale commercial or residential scale projects where the contractor is also invested to make sure that these things flourish. It looks good for all of us when what goes in the ground becomes a really healthy, thriving plant. So if there can be a coaxing into a way of doing things where, and yes, maybe it adds a tiny bit of tedium at the beginning, but look, if the proof is really in the flourishing of these plants on the other side, wouldn't you rather have that than be called back out in 6 months? Because man, these things just look, they're yellowing, stuff's not doing great. How do we help make this an obvious win?
80% of the plant species on this planet associate with mycorrhizal fungi. So I think it's a no-brainer from that standpoint. And I think people are coming around too. Maybe not everybody. And if you're going to be going out there with fungicides and just synthetic fertilizers, then again, that's all you're thinking about and relying on for the quote unquote health of those plants, right? It's like the IV approach where they can't really fend for themselves. They need a regular injection of this and that. There's no real resilience in that system as there's no soil health. Infiltration by pathogens and these kinds of things, it is going to occur. And I'm not saying that, just put some extract or some mycorrhizal spores and you'll never have pathogens again. It's more of a process, right? But if we look at it as a whole systems approach, we get to that goal a lot faster. But like kind of the set it, forget it, that can be tough too, right? You can do your best in the beginning, but I don't know how often you guys revisit your projects after maybe a contract term or something like that. What happens 3 or 5 years down the road with it?
Yeah, I think we try to set our clients up with this is what you're going to do to keep it at this state. Of course, our clients become our friends. We get to go back and see them. But like every summer, we want you to compost extract with mycorrhizae once a month, or give them the keys to the castle so they can be empowered.
Yeah, and I will say I spend a lot of time working on soil fertility recommendations and crop nutrition programs. I do a lot of sap analysis through the growing season so I can see the nutrient composition in there, and we formulate basically real time in season, and we can still make a change with foliar and fertigation type applications. There is a big focus on that side too, but I try to do things in a way in which there's synergy still between those microorganisms. And I think we've gotten closer to finding that sweet spot, if you will, with managing kind of all of these different factors that we've talked about. Oftentimes we're working in monocultures. I'd love to see more diversity. I'd love to see more perennials, more ground cover, more cover cropping, these kinds of things. Yeah. And I'm sure you would too, but a cover crop, hey, let's cover crop this, and then we'll come back in the spring and we'll do all this.
So my last real question, because we see it so commonly, especially this time of year, is that we are watching people herbicide their lawns, their parking strips, their sidewalks, and being newly a beekeeper, I'm very interested to hear from the soil microbiology scenario. Is there anything that you see safe? I'm really worried about these long-lasting chemicals in our soil for not our children, but for children's children.
Yeah, I think there's a lot of ways to go here. As you build soil health and you keep a living root in that soil all the time, so you have competitive exclusion from that side of things, you're going to see less weed pressure, but that can be a long game for sure. So what do we do in the short run? And what do we do around the residents and that kind of thing? Firstly, I'm just going to be a big proponent of pulling weeds.
Yeah. I have a lot of blackberry thorns.
That's right. Get a new tool, get some knee pads, whatever you got to do, get a sun hat and get out there and do as much of that as you can.
Too. In an environment where you just need to get some stress and aggravation through the body.
Yeah. And sometimes you could feel a little defeated if you have a lot of weeds to pull, right? So if we let them get to that point, I would say just behind fungicide in terms of soil health and soil carbon and all the things that are downstream from there.
Sounds like there isn't anything safe. I'll give you an example. So like right now, there's these Earthwise herbicides that are being marketed with horticultural vinegar and salt.
I've used it before, and I think when you brought up the driveway, sure, like why not use it in the driveway? But saying, oh, it's just such a small amount, I could say that about glyphosate too. So that whole thing doesn't really fly. Does it tend to build up and accumulate? Yeah, I think if you're putting sodium chloride in your soil and there's vinegar there too, there's going to be a detriment. But if it's your driveway, I think your kids are safe, let's say. So the glyphosate's not going to be there, or if it's 2,4-D or dicamba or atrazine or any of these other herbicides, it's going to be a lot safer. I think mulch is another answer to this question, and wood chips are, I think, a good type of mulch for people to use, even compost. Beyond that, just having a living root in that soil. If you're worried about weeds growing somewhere and something else can grow there, what can you plant? Can you plant some native forbs and maybe some milkweed for the butterflies? Not to get too like butterflies and unicorns. What are some solutions? And I think those are some. So mulch plants, both. Treat like the rest of your soil if there is an opportunity for that, and pull those weeds. And there's a ton of these burn down herbicides, and there's different things in them, from thyme oil to eugenol to caprylic acid to all kinds of stuff. And it will burn that waxy cuticle off that plant down to the crown, if you will. A lot of them are going to regenerate and grow back. Maybe not all, if you get them young enough, right? If it's a rhizomal weed, bindweed, quackgrass, everybody's favorites, right? Then that's a tougher scenario for sure, especially if you have problems with that in a space where within agriculture or where you're trying to garden. And if it's for home use and you want it as a productive area, I think the best approach if you have bindweed, quackgrass issues is perennials. So get some fruit trees in there, get a perennial ground cover in there. Even if it's something unconventional, it could be alfalfa, you know what I mean? Or some clovers, get some wood chips on the margins and around those fruit trees, and stop disturbing that soil so much, because bindweed just gets worse and worse with disturbance. Beyond that, pull some weeds.
Great. We're here for that.
Yeah.
Sorry, everybody. There wasn't a quick answer to that one.
Can I ask you one wild card question at the end? Because I'm curious.
Of course.
I was reading the OEN magazine not very long ago, and I came across this product of pelletized wool as a soil builder. And I'm really curious to hear any of your thoughts or experience.
I think we're in the same boat on that. No, I've heard about it, but I don't really know much about it.
I got a sample of it. I haven't started testing it out yet. I'm really curious.
Do you know, I don't know what like the mode of action would be for the wool. Is there any indication of why it works, how it works?
I'm not sure. It's meant to be a slower release fertilizer sort of situation, plus has water holding capacity to help regulate water in drainage situations. That's as much as I know. That's me being curious in the last 3 weeks.
I don't know much about that one. Kind of final thing on weeds is they're just letting you know what kinds of issues exist in that soil, whether it's compaction with thistle and things like that, or even bindweed, or just that it's not very developed successionally or ecologically speaking. If you have an old growth forest on this side of the successional spectrum, you've got like the weedy lot over here on this other far end of that spectrum. And so we've got to figure out how to push it this way more. And you can't really do that without establishing more plant life in those areas. But again, if it's concrete or gravel, that kind of thing, then I don't think there's harm in using the salt, vinegar, sodium solution. But I don't know how well it's going to work. Yeah. In a lot of cases, I think just pulling the weeds works a lot better. But if they're young and there's a bunch of them, maybe you can get out there and get a head start that way.
Yeah. Or back to your flamethrower.
Yeah. The good old torch flamethrower.
Oh yeah, I have one of those too, and I use it actually.
Right?
So I'm glad you brought that up.
I feel like that's a perfect solution for the driveway, the gravel pathway.
That's what I did with my driveway this year.
I feel like we've gotten all sorts of topics, plus all the ones that you said could be an entire podcast in and of themselves.
Yeah,
so
I know. But microremediation and phytoremediation, I'm super here for on another topic as a deep dive.
There's research out there. Poplars are good trees for phytoremediation.
Oh man, see, we got to keep going.
There's good information out there. I think phytoremediation is a really good way to go, but there are also plants like cannabis plants are amazing bioaccumulators that can go from a seed to a 15-foot plant in a single growing season. And there's a reason for that. It pulls a lot. So want to be careful about where we're planting that kind of thing, but we can also leverage it for phytoremediation. Just don't want to make CBD or something like that out of it afterwards.
Don't want to smoke it. It sounds unhealthy.
No, probably not a good idea. Not going to be good for your health, no.
This has really been eye-opening. There's so much here for people who know something about soil. There's so much here if you can speak some lingo, and then there's some really good take-home notes if you get washed over with a lot of the scientific jargon that's been used.
I'm used to that, yes.
And if you dive through it, you can also find some pretty easy take-home notes for the basic landscape. And I feel like there's value in that. And I know going forward, we're going to keep doing a couple inches of compost as our spec. We're going to keep bringing in mycorrhiza. Now we're going to get this blend of mycorrhiza because now we know that there needs to be 2 different types of species that we bring in, or 2 different classes of species that we bring in. And we'll start to use compost extract instead of compost tea and inoculate it.
That's very exciting.
Be thoughtful around the biochar frenzy and keep our slow and steady experimentation with all these things. To
Yes,
figure out what's
let's stay in touch
what's
about
really
that
working.
because I think it's going to take a lot of different minds coming together to figure out what is ideal with biochar. And everybody's talking about it. So we just talk about it collectively and share our positive experiences with it and some of the negative ones, like what I shared here. But the mistake, I think, is a tool with the right perspective. And so a lot of what I've learned has come through mistakes. And so when I'm making mistakes, it doesn't always feel like it's ripe for opportunity, but that is the reality of the situation.
It's
I feel
useful.
you.
We keep on taking all those things and factor them in next time. That's humanity. That's our course. That's our challenge.
Yep. The error correction, very important for sure.
Got to keep growing.
Thanks, Nick. This is so fun.
Yeah. Thank you guys for your thoughtful questions and for having me. I really enjoyed it.
Do we find you anywhere online?
Yeah. HumankindOregon.com, at Humankind Oregon on Instagram. Thank you so much.
Thanks for coming.
Thanks, Nick.